My name is Chris Baker. I'm a several year coach, volunteer, referee, a few other roles, First Long Island. And what I'm here to present to you today is a Beyond the Basics tutorial for EV3 and Spike Prime. I have had a little bit of experience with Spike Prime over the last year. Many of the lessons that I'm going to be providing should cross over to both. There are slight differences between the two platforms, but everything here really should, it's in principle the same platform. I guess I'm just gonna go ahead and get started. I'm gonna share my screen. This one here. Share. I'm gonna present. Oh, I just did this a minute ago. Oh, where's that present button? There we go. There we go. Okay, so sorry about that. I had to switch rooms suddenly. I had a technical problem with my other computer, so I had to switch rooms. Everybody seeing my screen there? We're good there? I hope so. Okay, good. So welcome to First Lego League Challenge. I would imagine I will get to the questions in the chat in just a couple of minutes. I'm going to go a couple of slides in and make sure I cover, not get too far ahead of myself and cover the challenges. This is First Lego League Challenge. So what I'm going to assume is that everyone here, is that on the screen? I'm going to assume everyone here is familiar with what we're talking about when I say EV3 and Spike Prime. I'm going to assume everyone knows what First Lego League Challenge is. And if that's not the case, go ahead and either post in the chat or let us know and we'll get you over to the other presenter. That would be Eric, who's doing a simple cover the basics for new coaches. So EV3 is a long-term platform. It's been out for about 8 years now, and Spike Prime is coming in. As far as we know, both platforms will be allowed in competition for at least a couple of years to come, and they're both good and different. So let's jump right in here. Go slide. There we go. So the things you're going to need to compete this year in the robot game, you're going to need obviously a laptop computer, a Chromebook, or a tablet, which has the most recent Lego education software, which is a Scratch-based software. It's a really wonderful program. It's, I feel, an improvement from the previous blocks-based dragging program that was there before, because what's really nice is most of your students come in are going to be very familiar with Scratch-based or Hatch or whatever platform that they've been learning to program was Scratch-based. So it's really up to the kids to learn to program. So we're here to, like Troy said earlier, the kids do the work and we're here to guide them through the process. So you're also going to need a First Lego League Challenge kit. You're going to need the table built that fits the challenge kit. Like I said before, what is Scratch? Scratch is a visual block-based programming language. If anyone needs to stop me now and say, what is Scratch? Go ahead and do that and I'll return to it. But from now, I'm going to, again, assume everyone knows what the Scratch-based EV3 education software is, and I'm going to go on. So I know I only have an EV3 picture here, but again, this is for both EV3 and Spike Prime. You have the option when you program your robot to either plug in the USB cable to download and then run it from the brick, or to connect Bluetooth and run it that way. But again, like Troy said earlier, when you do your official robot runs, you're going to need to run your programs directly off the brick. So you're going to program on the Spike Prime, like your program numbers 1 through 9, and run the programs from the Spike Prime instead of hitting play on the laptop. So I'm going to go over the basic components here. The Sensors. All right, obviously we have different sized motors on the Spike Prime now, whereas on the EV3 we had large and medium motors. On the Spike Prime, we also have large and medium motors, but they're just shaped a little bit differently. When we talk about motors and sensors, technically the motors also have sensors built into them. They're called encoders, and they do measure the wheel rotation, how far that motor has turned in either rotations or degrees. And what's really nice on the new Spike Prime motors is they actually have built into the programming where you can zero out a motor. There's a little mark on the motor rotation where you can bring that mark back to zero, so that if you have an attachment, you always want to be standing in a certain position. In the coding, in the Scratch programming, there's a button that you can say, bring that motor back to zero. It's a really nice addition to the programming that was not available on EV3. The sensors available on the EV3 are the touch sensor, as you can see in the graphic, recognizes the conditions touched, bumped, and released. On the Spike Prime, the touch sensor is a little bit upgraded. It's now a force sensor, and it actually measures how much force is applied to that sensor in newtons. There are tutorials available online to get deeper into that force sensor. On the EV3, next to the touch sensor, you have a gyro sensor. That is a single axis gyro sensor, and that when it is face up, it measures your facing in degrees. When you reset that sensor, it resets to 0. And as your robot progresses down the field, it turns positive to the right and negative to the left in degrees. It measures your facing. On the Spike Prime, the programmable brick actually has a built-in 3-axis gyro sensor. What's really nice is, so if your Spike Prime is laying flat, you have X, Y, and Z axis, which is, if you're into aviation, it's pitch and yaw and heading. So it's really nice to have an X, Y, Z axis built directly into the hub. So it saves you a port that you don't need for, that you won't be using for something else. The Spike Prime also has a new sensor also built right into it, which is the accelerometer. And it measures, I think, starting and stopping power. I have not really gotten into the accelerometer, but I know that that is a new built-in sensor to the Spike Prime. Both EV3 and Spike Prime platforms have color sensors, which are also reflected light intensity sensors. I much prefer, when I was doing my programming with my team, to use reflected light intensity on this sensor, because it just seemed to be a far better use of the sensor than looking for a specific color, mainly because if you're looking for a specific color like blue or green or red, the lighting conditions you might have when you're working at home or at school might be different than the lighting conditions that we have when we're working in a gym. So reflected light intensity does change also in those conditions, but it seems to be more consistent when you move place to place. So that's a difference in the color sensor. I'll get into a little bit further into that. Also, next to the color sensor is a distance sensor, what's it called? I'm sorry, a ultrasonic sensor. Now, ultrasonic sensor measures distance by sending out sound waves and measuring how long it takes those sound waves to return to the sensor, thus measuring distance in either inches or centimeters. We always prefer doing centimeters. The Spike Prime has a very similar sensor. I believe I've covered all the sensors there. I'll get a little bit deeper into that in a couple of minutes. So I'm going to just check out the chat real quick and see if there's any questions here leading up. Do you know why the robot doesn't always go the same place when you start at the same place? If you go in a straight line, sometimes it veers left to right. Yes, there are many factors that might lead to that happening. So first thing I would check is to make sure all the tires that are on the hubs are perfectly set into the hubs, because sometimes when you put those tires on, or if you drag the robot left and right, or you pick it up and you put it down, one of the tires might actually come ever so slightly dislodged from the hub. and that will cause the robot, even if you have both motors driving forward, it will cause it to veer off. There are other factors where something might be dragging on the ground. So if you have wires hanging out of the EV3, it could drag on the ground and it could cause it to veer off. There are many different factors. There are ways. So first thing I would always check is everything on the robot. Are the tires always pushed all the way in? Are the tires flat? Are the tires even? Is there something impeding one of the two tires? Or is there something dragging on the ground? That would definitely cause the robot to veer off. And over long distances, motors are just different. No two motors are perfect. So over long distances, you will have the problem of the motors not exactly turning at exactly the right motor rotations. So one of the ways we mitigate this problem is you can use the gyroscopic sensor to drive forward in a straight line. There are tutorials available on that. It's called angle following. You can also use the lines on the mat, the walls on the mat, any landmarks you can find on the mat to drive to as close to that point as you can. Use your sensors like your reflected light sensor or your distance sensor, or again, your gyroscopic sensor, to align yourself once you've reached further down the field where you want to be. I hope that answers your question. There's anything else? You. Okay, that was good?
Yep, thanks.
Okay, great. Okay, I'm gonna move on here. So, how the sensors work. This is ultrasonic sensors. The top sensor for both on the left would be the ultrasonic sensor for the spike prime. On the right is the ultrasonic sensor for the EV3. They work the same way. You're going to measure distance in either centimeters or inches, whatever you're more comfortable with. You're going to face that in the direction that you want to measure. It is very specific as to how you point it. And it's an excellent, excellent tool for moving further down the field and getting to a point where you want to stop and make a turn. So, for example, if you have a weight block, you're going to go forward, wait until ultrasonic sensor is 12 centimeters. So you're going to drive until you're 12 centimeters, and then you're going to stop the robot. I'll get to the stop the robot in a later slide. Then after you've stopped your driving, you can then either turn or manipulate an object or something like that. That's the way an ultrasonic sensor is best used. Color sensor, good for using the lines. If you have a face down color sensor, one or two studs off the mat would be a really wonderful distance to have it off the mat to measure, to follow or navigate on the field using the very thick black lines on a white background that they give you to navigate down the field. Touch sensor, which on spike prime is also a force sensor, good for sensing a wall object, so that if you have a forward facing sensor and you want to get up to a wall, you're going to use that touch sensor to drive up, hit the touch sensor, and now you're at a very specific place on the mat where you can now continue to navigate. Gyroscopic sensor. Oops. Nope, I want to go back. There we go. Gyroscopic sensor. Okay. It is what I have found in my years of coaching First Lego League is the most useful and most difficult sensor to use. My high recommendation is when you place the robot on the field and you start your programming to do a task, to run out and do a task, you're going to place the robot, reset the robot. Don't touch the robot for a couple of seconds. Let the gyroscopic sensor reset. Let it point to 0. Look at your computer if you have it Bluetooth, if you have it, and make sure that gyroscopic sensor is at 0 and not what we call drifting. So if you're looking at your laptop computer, you have your robot on the table, you've placed your robot, you're ready to do your run. Quick look at your sensor ports. And if you see that gyroscopic sensor is going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it's not moving on the field, I would reset that robot, either turn it off and on again or unplug the sensor and plug it back in, make sure it's at 0, and then do your runs. There are very, very good resources on how to use that gyroscopic sensor on ev3lessons.org. Those are a couple of First LEGO League alumni that have done extremely well in competitions, went on to World Festival and did extremely well there. ev3lessons.com is great. Another really great resource is on YouTube, is Builder Dude 35. His name is Kyle. I've met him in person. He's a really great kid. And he's also a First LEGO League and First Robotics alumni right here from Long Island, from Port Jefferson. Really great. I'll get a little bit deeper into that in a minute. This is the new Scratch programming. This is a little bit different than what some of our experienced coaches might be used to. Everything is really nicely coordinated into colors. You have the blue dot, which is your single motor. If you want to just run a single motor, that's the blue dot. If you want movement, the pink dot will do what's called driving or dual motor. Display, sound, events. I'm going to get into all that in a minute. But what you can see on the screen right now, there's a lot of information what you're looking at right now on the screen. So we have our project open at the top. We're in the blue motors tab. What you see next to the blue motors tab is you see a picture of your EV3, a tiny little depiction of your EV3 with a green light. That means you are currently connected to your EV3. If you see a red light, you are not. And you'll have to go through the steps to either connect through Bluetooth or through the USB cable. Next to that, you're going to see motors A, B, and C. They are large motors, and it shows the ports that they're connected to and how much rotation they've already made. So those values are resettable. You can also set them to reset at the beginning of your programming, or just let them go. If you are measuring degrees, I highly recommend at the beginning of your programming, you reset those at the beginning of programming every time you're going to do a run, or you might hit values that you're not expecting. You might have unexpected results in your runs. Like you might expect it to drive up to a mission and perform the mission, but what happens is it sits in base and tries to do the mission from base when it hasn't driven forward, because by turning those motors in advance of running your runs, it feels like it already satisfied the condition for driving forward. So you reset those degrees driven, and you won't have that problem. Is everybody following me? If anybody has any comments, wants to stop me, please post something in the chat, and I will. I'll pause. I'm going to give that a second. If I'm going too fast or going too slow, please let me know. Okay, I'm going to go on. So the difference between the EV3 and the Spike Prime ports. Like I said before, the blue dot functions are for moving a single motor. Now, on the Spike Prime, you have 6 ports to plug into, 6. And those 6 ports are for anything. You can plug a motor in, you can plug a sensor in. Those 6 ports are good for anything you want to plug into them. And built into the Spike Prime is the accelerometer and the 3-axis gyro. On the EV3, which many of us are still using, there are 8 ports. There's no built-in sensors to the EV3. There are A, B, C, and D, which are your motor ports, and 1, 2, 3, and 4, which are your sensor ports. They are not interchangeable. Motors go into A, B, C, D, sensors 1, 2, 3, 4. Yes, there's more ports on the EV3, but there's more built into the Spike Prime, so there is a trade-off there. And the Spike Prime, the brick itself is physically smaller, but it doesn't have a display on it like the EV3 did. It just has an LED display where it shows, I guess it shows numbers or a face, whatever you want to do, whereas the EV3 had a lot more information on the screen, but also that could lead to a lot more confusion. Okay, so now we're gotten into the pink tab. This is The driving around block, as you can see on the left side, move forward for one rotation, move straight. You can change that facing. What that'll do is that will, when you change that facing, it will allow you to turn either slight turns or sharp turns, depending on how you want to turn. Now, if you look at the fourth block down, there's a block called stop moving. This actually is a really, really, really important block, a very underused block. So if you are moving forward and using a sensor to move forward, such as you're going to wait, move forward and wait until your ultrasonic sensor is at 20 centimeters. At the end of that wait block, after that wait block, definitely put a stop moving block. Then move on for your next driving block, because if you, just like in a car, if you're driving a car and you press the accelerator and you're going forward, and then you want to make a turn and you turn the wheel, the car continues to keep rolling forward into that turn. Whereas what the stop moving block does for you is you hit the accelerometer, then you hit the brake and you stop the car. Then you turn the car and move forward. That stop moving block is the brakes. You've stopped moving up to the point where you want to stop and then go forward from there. What that does for you later, if you're doing, especially if you're doing several missions down the board, what that does for you is it gives you much more accuracy on your third or fourth or fifth turn. Whereas if you don't use that stop moving block, your results further down the board are going to be much more inconsistent. I love that stop moving block. Any questions up till now? I don't see anything in the chat, so I'm going to, do I not see anything in the chat? Okay, I'm gonna keep going. Okay, we're gonna jump all the way down to the sensors tab here. I'm going to spend a little bit more time on this tab. I hear someone typing. If you have a question, go ahead and ask that question. So the top tab that we see, the top block that we see at the top of the sensors is reflected light intensity. This is an extremely useful block. And you see there's two different shapes because they are going to plug into I'm sorry, you see three different shapes because they're going to plug in different ways into your programming. The reflected light intensity, what happens is there's two ways to use that. Either you use the ambient light in the room to see the lines, or you're going to turn on the light on the sensor and you're going to use the reflected light from the sensor to bounce back. I highly recommend using the latter. Reflected light intensity from the light is very consistent, so that if you have your color sensor face down on the mat and it's seeing a white part of the mat, your reflected light intensity is going to be a very high number. It's going to be 80s, 90s. Your reflected light is going to be very high. Whereas if you have your color sensor pointing down at the mat and you see a black line, or I should just go to black line, your reflected light intensity is going to be extremely low, maybe 10 or 20. So that if you're looking for reflected light intensity and you're on the white and you're looking for a black line, you wait, you move forward until the reflected light intensity is under 50%, and then go back to that stop moving block and stop moving at that point. I'm gonna wait, pause for a second, see if there's any questions. Nope, we're good. All right. Oh, I got a question here. Okay, so the question is,
that doesn't seem to be in my.
That's right. So the wait block also stops moving the robot. Not necessarily. The wait block waits until a condition is met. So if you're waiting until you see, let's say you're using your ultrasonic sensor. We don't seem to have reflected light intensity in our sensors list. I'm not sure why, but if you're using a wait block to see a wall, but you don't give it a command after that, it will continue to drive forward until you tell it to do something else. That's where that stop block comes in. Stop is a guaranteed.
Yeah, he responded to it. He's like, I'm not sure why you don't have that. It's just, okay.
Yes, there is a wait. There is a timer block. I think it's just not on the screen. I don't have it in this slide. Yes, there's a wait. There is a timed block. Actually, I think that's actually built right into the movement block. Okay, so if you look at the movement blocks, you can move forward for 1, and then you can change that value to seconds. You can actually move forward for.
Can you expand that? Can you like make it? Can you pull it out onto the board and then make it wider?
Yeah. This is actually just a PowerPoint slide. I don't have the actual software.
Can you stretch it at
all? I don't think I have that loaded on this. I'm sorry. I was ready in another room, but I had actually. Let me see if I can. I'm going to launch the EV3 software and see if I can do that, and I'll come back to that. Okay, I'll come back to that at the end. So these are the, as I was saying earlier, these are the 2 ways that we can use the color sensor, or what I prefer to use the reflected light intensity. You can, the first block here is wait until, and the plugin is.
Well, that's this one, I think. He's using this. Intensity, maybe a percentage.
I'm sorry?
All right. And then you got one of these?
I'm sorry, are you?
I think they just need to mute.
Okay, I'm not sure if you were talking to me. Okay, I will share this part of my screen. Stop share. I'm going to share screen, go to share. Okay, now I'm actually in the software. So what you were asking me was, so we have when the program starts, I'm not connected to my EV3. You can see here. Can everybody see my screen right now? If you can't see my programming screen, let me know. We have your start block. This will happen when you press start on the robot. Now, at this point, we're going to start moving forward for 1 rotation. At the end of this block, in theory, the robot stops driving. But what I always like to do after every movement block is stop moving and then stop and end program. This is just really good practice for future programmers to know process, to know this is what we want to start, this is what we want to accomplish, and this is where we end our program. So instead of move forward for 1 rotation, we can actually go for seconds. So we move forward for 1 second, stop moving, stop and end program. An alternate way to do this is we can start moving. We're now going forward indefinitely. Where's that? We wait for an event to happen. In this case, 1 second. We drive forward for 1 second. Now we have to put the stop moving block or it won't stop moving. It will drive forward for a second and then unexpected results. So if we give it a very specific command to stop moving, it stops at exactly the end of 1 second, and then we finish an end program. All this does is drive a robot straight for 1 second. I would say yes, only because it's really good practice, so that if you are here and then you want to continue on, or you want to turn the robot now, you want to turn right for 1 rotation, then stop moving, then stop and exit program. It's just really good practice for the programmers to have very clear defined parameters that you want that robot to execute. You know what's going to happen because you told it that's what's going to happen. If you don't put the stop moving and you don't put the stop and exit program, you will have that end result that you're not really sure of what's going to happen. I hope that covers it. Yep. Okay. All right. I'm going to leave this open, but I'm going to go back to my PowerPoint presentation here. Sure. Okay. So I'm going to go back to the slide. This is the 2 ways to use the color sensor. This works for both the Spike Prime and the EV3. So before this program, you would be moving forward, then wait until the color sensor, which is in B. So in this case, this is actually pertaining to the EV3. Oh no, I guess it's both. I guess they both have the letter slots. And then you're going to stop moving when you sense color black. You can change that variable to any color you want, or you should get the same result if you wait until the color sensor in port B has a light reflection of less than 50%. This way, anything you come across on the mat that is a darker than a light reflection of 50% will stop the robot. So depending on which action you want, I've always found that the light reflection works a little bit more consistently than looking for a specific color. Okay, all right, here we go. So one of the more advanced techniques that I like to use is what's called line following. What this program does is it actually follows the edge of a line between the black and the white edge of a line and does what's called fishtailing. So what you're doing here is you're setting movement to your 2 driving motors. Your driving motors in this case are in A and E ports. They're presumably both faced in the same direction, so going forward. So you press play, you set movement motors to A and E. Now we've entered what's called a forever loop. We've entered a loop block. So in this case, the condition will never be met. You'll just always drive forward until you end the program. But this is just an example. This is just showing you how to do line following. So inside the loop block, if in the blue plug-in, if the color sensor, which is plugged into the B port, is color black, meaning your color sensor is over a black line right now, you're going to start moving with your left motor at 40% power, your right motor 20% power. So it's going to steer ever so slightly to the right. And you're still in that block, and many times per second, you're going through this loop. So it's driving. Oh, all of a sudden, you're no longer over the black line. You're now over a white line, or as you can see on the block on the right, over 50% light intensity. All of a sudden, you're now going to execute the lower pink block, the lower pink driving block, which is start moving with the left wheel driving slower than the right wheel, which will now veer your robot ever so slightly to the left. And again, your loop block is running, you're driving forward, a little to the left, little to the left. Now you've under 50% light intensity, over 50%. And what ends up happening is you scooch forward and you end up driving in a very nicely straight line because you're striking the edge between the darkness and the brightness, and you're going straight, following that perfect edge between the black and white on the left line. So this is what we call line follow. These actually same principles in a little bit more advanced tutorial pertain very well to the gyroscopic sensor, whereas instead of using reflected light intensity, you're using the angle that you're following on the gyroscope, but that's a little bit more advanced. If we have any questions about this particular block, go ahead and post them here. I can wait here for a second. There's usually a lot of questions about this one. The question is, are robots very unstable while doing this program and gets confused on the turns? How do we, okay, that's a very good question. So what's happening is, it sounds like you're following a black line, but it's not a perfectly straight black line. It's a line that turns. Yeah, there's a lot of trial and error in there because it depends on how far off the mat your color sensor is, how fast you're running the wheels. I would say the first thing you do if you're confused and you miss turns is definitely slow down the robot. Instead of using 40-20, try it at 20-10 percentage and see if you slow down the robot, it makes better turns. Or do slightly more sharp turns and use 40-10 and 10-40, because that, instead of doing slight turns, it'll actually do much more abrupt turns. So that might follow a line better. Or what you could also do is, if you know that you've reached the end of a straight line, have a timer go fast, have a timer go to where you're going to get really close to the edge of that line, end this loop, start a new loop after, but go much slower so you can scooch around that corner. There's lots of different ways to, there's infinite ways to solve this problem. And without seeing your particular runs, it's really hard to say, but generally it's a speed issue. It's a size of the tires you're using and how far your color sensor is off the mat. And when you're using reflected light intensity, are you using the ambient light, which is in the room? Or when you turn on the color sensor, does it actually project the light down onto the mat and reflect that way? Because I found that tends to be more accurate. With that. How do we control how many rotations the robot moves while line following? Many different good answers to this question. So instead of using forever loop, let me go back to share screen. I'm going to go back to my EV3 software. So I'll take this whole, put it over here. Control. So this is the block we're going to use to control how far the robot goes. So a simple example is I'm sorry, that's the wrong one. We're going to start moving straight. Now, at this point, we're in a loop, and we're going to set the conditions for which we want to stop. So the condition we want to stop is we want to drive forward over the white part of the mat until we reach a black line. So where's the set? Before the loop, our driving motors are in B and C. So our left side is B, our right side is C. We're going to enter the loop, and we're going to assume that we're over a white part of the mat. So if we're over a white part of the mat, reflected light intensity is greater than 50%. So we're going to drive forward. And again, in that loop, we're going to start driving forward. Now, when this condition is met, that the color sensor in port 3 is greater than 50%, we stop moving. Excuse me, I thought I was going to sneeze there. So this is how we stop moving based on a condition in a loop block. Yep. Does that? I'm sorry, I just lost the chat there for a moment. I hope that answers that question. So how do we control how many rotations? So instead of using this, how do we control how many rotations? That's a good question. Oh, that's in a different place now. Normally I thought the rotation sensor was in there. I don't want to waste everybody's time. I'll come back to that, but this is where you would put any condition that you want to stop. Okay, so how do we do this while line following? Excellent question. So instead of start moving straight, let me go back to my screen sharing. In this case, I'm just going to go back so I'm consistent with this. Okay, so we have a forever loop and then we have an if then else. Okay. So now let's go back to here. So instead of that forever loop, we have a repeat until. So we can have let's see what we got. Let's do a repeat until. Here we go. Nope, wrong one. Missed it. There we go. Control. Okay, so here's our loop. We're going to enter the loop. And here's the conditions. Nope, again, wrong block. There we go. We're going to set our movement. Just like in the previous slide. Right? And that's if the reflected light intensity. Now, this is how you stop moving at a certain condition. We start the program here. We set movement to our B and C motors because now we know that our left motor is in B and our right motor is in C. We repeat until the distance sensor, the forward-facing distance sensor, is less than 15 centimeters. Okay, we enter our if then. It says if reflected light intensity is less than 50%, we're going to move to the right. If it's greater than 50%, we're going to move to left. This if then else statement will continue to run over and over and over because we're start moving. We didn't move we didn't move forward here. We didn't use this block in this place. We're not moving for a condition. We're just moving forward until your distance sensor is less than 4. It breaks this loop and we stop moving. Stop moving. So now we followed a line up until the distance sensor says stop. There's lots of different ways to change where you stop. You can stop on time. You can stop on motor rotations. There's lots of different ways to do that. The spike does not automatically have all the blocks when you start up. That might be the version that you're using. I believe if you go to Lego Education website, it has all the blocks for the sensors that came with the education set. If you have a retail set, I forget the name of that set. If you do the retail version, it'll come with only the pieces, the sensors that came with the retail version. I think it might be the version you have. And again, so yes, you have to click on the bottom to get it, correct. All right. I hope I'm not going too fast. I hope I'm not confusing here. I'm going to go on with the slideshow. Share. And share. Okay. So I hope we've covered, this is a basic line following. Again, a lot of these numbers are going to be based on what ports you have your motors and sensors plugged into. It's going to be based on the size of your wheels. You have really small wheels, you have really large wheels. Your speed is based on the size of your wheels. So what we're not saying is go forward at this speed. We're saying go forward at the percentage that the motors say to go forward. So your speed will be based on the circumference of your wheels. And here's that. Here's that slide. Circumference of a wheel is based on this formula. So one rotation on a smaller wheel will go only a certain distance. One rotation on a large wheel will go a much further distance at a much greater speed. Any questions on that? If not, I'm going to move on. Okay. When it comes to coding your robot, and this actually is a really good practice going forward for any of your future coders who are going to use Python or Android Studio or any of the other programming languages. Commenting on your code. This actually works really well for your coders. It works well for your coaches. It works well for the judges who are going to look at your coding. Commenting on your code. As you can see, you can right click on any block to add a comment. And these comments are not actual code. They're just there to tell anyone looking at your code what's happening in your code. So type your comment, resize the box, and on the right side, you can see the little tan box that comes up and says, what this code does is it allows us to move forward until we find the wall, the north wall next to mission 7. It's really nice for your coders because, excuse me, I just gotta get the charger out of here. Okay. Sorry. I have a First Lego League alumni walked into the room behind me here. So yeah, commenting on your code is a really nice way to tell the judges what's going on, to tell your coders what's going on, and even nice for if you have groups of students working on code and you have you have your 2 coders on Monday and your 2 coders on Tuesday. So if the Tuesday coders come in and say, oh, what were they working on Monday? The Monday coders commented their code. It's really nice to easily see what they've done. And it's really, again, like I said, it's a really nice practice going forward so that later on, if you're working in Python or Java or something like that, it's really great to have comments on your code when your code is many, 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 many hundreds of lines long. Okay. All right, so some of the, this is just advice from an experienced coach. Always check your ports. When you come in on a new day and you run the code that you've been running for 3 weeks and you put the robot on the table and it doesn't do anything like you're expecting it to do, first thing you always do is check your ports. Make sure your motors are plugged in. Make sure your sensors are plugged in. Check your port view in your software to make sure that someone didn't come along. Oh, I meant to tell you that I swapped these plugs because they came out. So one of the easiest way to solve problems is check your ports. A lot of times your coders always want to pour through the code and start changing code. Oh, how come it's not working the way it did a couple of days ago? Check your ports, check your hardware first. When you're approaching a scenario like line following, or you're approaching a mission, there are infinite ways to solve that mission. A lot of times your builders and coders will be stuck on, we're going to go up and we're going to lift that lever. There might be many, many, many infinite ways to solve that mission. Don't get stuck working on one way. If it's not working, shelve it, try a different way. You might go back to your original way, but more often than not, you're not going to go back to that original way you were coding up that mission. Like I said, stop the robot after every movement, because that way you know the robot stopped. I found that to be especially important when you're coding up the EV3. I have not had enough experience with Spike Prime to find out if that's super important, but I have found with using EV3, definitely stop after every movement to know exactly where the robot has stopped. beyond what I've told you here today, there are far more complex programming blocks built into the Scratch-based programming in Mindstorms. There are variables and event blocks. You can have 2 trees of code where this is your start block, and you have an event block running simultaneously. So you're going to drive. But if you're looking at the force sensor inside the spike prime and it tips over, you can have that force sensor say, oh, stop moving, because you don't want to cause further harm. Have to go pick up the robot, bring it back. So there are many more, and a lot of these tutorials are available on ev3lessons.com. Again, those are experienced First LEGO League alumni that have been through all this. Another piece of advice, make sure to read the coach's manual, the whole thing, all the way through. Check for game updates regularly. Troy did a very thorough job going through all the mission models, but there will be clarifications through the season. So make sure to check those regularly so that if you show up to the tournament and say, oh, we didn't know that, was that an update that come out? It's really on the coaches and the students to make sure that you are up on the most current rules when you arrive either virtually or in person at the tournaments. Any questions about any of this? We're good. We still got some people here, so I guess we're going. Oh, we have a question. On spike, the relative position keeps going negative. How do I tell it which motor direction I want to be positive? Okay. It depends on how you have the motors facing when you've built the robot. So if you have a robot, this happens to be my phone. That's not going to work. Robot. And you have a wheel on one side. If you've turned the motor upside down, it'll actually be going in the negative. So you're always going to be driving negative in your mind with what is the front of the robot. So your options are unbuild the robot, flip the motors upside down. Now they're going forward. Or nope, if you switch sides, it's not going to be, it's still going to be the same. Or in your programming, the first line of code, what you can do is set your driving motors to be going backwards. So then the rest of the code, your driving motors will be going forward. Hope that makes sense. Let's see if I can show you in the programming there. Let's see if I can screen. Mindstorm share. So I believe there is a movement block. No, I'm used to the EV3 programming. No, it's I guess that's one of those other blocks that you were talking about earlier where you'd have to add that block. Set movement. No, I'm not sure. I don't want to waste too much time on this, but yeah, it's the way you've mounted the motors on the robot that backwards is forwards, that the front of the robot is going forward with your encoders in the motors instead of backwards. And you can either flip those motors upside down or change it in the programming. We had that case a couple of years ago on a robot where we had built a custom robot. The motors were backwards and we just drove backwards the whole season. And it was actually a really nice exercise for the students to always have to remember we're driving backwards the whole time. I actually liked it very much. I thought it was a really good exercise there. Okay. What you could also do as a tool for your team, and also something to present to judges in the robot design, have a flow chart, a diagram represents the workflow or process. It could be something you make in a PowerPoint presentation or just something you have on a piece of paper that you've drawn out. A simple step-by-step flow chart of where do we start? What direction do we start facing? Where in the home Are we lining up our robots so that we consistently drive in the same direction? Your flow chart will say, we've driven forward, we've followed a line, we've stopped at a wall, and we've ended. Just a step-by-step flow chart of where we start our actions and where we end. Your flow chart could actually be used for your engineering notebook later on as well to show the iterations and the progress you've made toward your end goal at the end of the season. Just another tool for you and your team to use to show your progress and again, if you have different groups of builders and coders, to show the other groups what the previous groups have done. There was a question earlier posed to Troy. Is it better to use the pre-built directions for a driving base, or is it better to build your own custom robot? That is really an impossible question to ask us, because it's really based on how strong you feel your team is to build a custom robot. It does require a bit of complexity. And do you feel that your builders and coders are up to the task of building their own custom robot? There's nothing wrong with using the pre-built robot, but like Trish said earlier, the judges do like a nice custom robot. But if building a custom robot is going to be a great detriment to your season and to your builders, don't do it. Don't hinder yourself by saying, we have to build this custom robot because that's what the judge is looking for. Really tailor that to what your team, what task your team is up to. Excuse me. Another thing to consider when you're building your robot: time constraints. If you are meeting 3 times a week, 3 hours a meeting, you got plenty of time. You got time until the January qualifiers come up. I would highly recommend time constraints, setting a goal for when you're finished with your robot. Maybe 2 weeks before the competition is a good time to say, okay, we're going to be done with our robot and we're going to practice our runs from here on. We're not going to make any major changes. We're not going to make any major changes to our runs, to our building, to our wheels, to our stuff. Set yourself a time limit and try to stick to that time limit, because if you're building right up until the day before the competition, things might go awry. And that is from personal experience. I know that very well. When you're building your robot, make sure to have a consistent starting position in the home base. Always run your runs from that consistent starting position. I've seen teams where what they want to do is they want to start their robot way out in the middle of the field, drive 1 rotation up and see if I can solve this mission. And they've perfected that 1 rotation drive up and solve the mission. But when they get back to the base and they start driving from home, all that goes out the window, because driving from home base and starting from somewhere in the middle of the field is 2 completely different things. So choosing a starting position, always start your runs from there. And that's going to save you a lot of trouble down the line. A consistent starting position. That means heading, facing, and make sure to be inside the boundaries of the launch zone. That means inside the wall, inside the lines, and that includes all your tools. Nothing can be hanging outside those walls. Yeah, when you're building your robot, if you're using a custom build, make sure if you're building a custom build, you can fit between the missions that are down the board. Make sure you fit down there. Some of those spaces down there are really tight. Again, consider when you're building your robot, your navigation and alignment on the Spike Prime. You are limited to how many ports you have. So if you have your 2 driving wheels and you have 2 motors that you're using to attach attachments to, that leaves you with 2 more ports to put sensors into. And you have to choose which 2 sensors you're going to use. Are you going to use 2 color sensors to follow lines on either side? Are you going to use a color sensor and a gyroscopic sensor? Or I'm not sorry, gyroscopic, but distance sensor? Are you going to use a distance and a touch sensor? You have a limited amount of ports that you're going to have, and I highly recommend not swapping out ports between runs. Like, oh, I'm going to use the distance sensor on this one, the touch on this one. I would not recommend swapping out. Like, if you're going to do your first run, we're going to do 2 missions. Bring it back to home, swap out the ports. I think that's usually a recipe for disaster. And accessing the battery. If you have the built-in battery like you have in the Spike Prime, or you have the built-in battery in the EV3, make sure you can access the port where you have to plug in your charger very easily. So you're gonna have to take something up, plug it in, unplug it, put something back in. Accessing the battery is really important. I know it sounds silly, but it's true. Okay, so would you go over the rules on using a jig? I have actually not read the rules this year on yet. That would be a referee question. That would be in the manual. I don't want to give you any misinformation. I'm not sure about the rules this year about going over a jig. I haven't covered that. Resources. Okay, so beyond this training day, there are an unfathomable amount of resources out there that are available to you. Check out the first website. There are tutorials. Read the coach's handbook thoroughly. Read the challenge guide thoroughly. Go over the core values. Please share your core values and practice gracious professionalism with your team during all of your meeting sessions and everything you do, so that way when you arrive, either virtually or in person at the tournaments, your students are well versed in the core values and are gracious professionals. First has a wonderful YouTube channel. They have really great videos, but again, make sure to watch that channel for updates during the year and for how we're going to move forward with our tournament schedule. Oh, there's a typo. First Long Island has some resources, such as this video is going to be posted on First Long Island. MIT has some wonderful resources. And like I said earlier, ev3lessons.com and BuilderDude 35 are really wonderful resources, have really great tutorials. Give me 1 second. I have notes written down. I'm going to take 1 second. I'm going to go get those notes. Sorry, I had to, like I said earlier, I had to move positions. So, all right. So I covered the robot design. Again, to reiterate something someone said earlier, make sure the students do the work. I know it sounds like, to your experienced coaches, you know exactly what I'm talking about. Everything that goes to the table, everything that gets presented to the judges, everything that's in the programming should really be student work. I'm a very strong advocate of this. ev3lessons.com. Oh, and BuilderDude 35, Kyle's actually a local Long Island alumni from Port Jefferson. He's a really great guy. Again, like Troy said earlier, don't launch your programs from the laptop. Teams often fall into a pattern when they're doing their iterations and building their tools and doing the programming that they launch their programs from the laptop. That's fine at home. That's fine in practice. But make sure when you get close to the tournaments that you're launching those programs from the programmable brick itself, from the EV3 or from the Spike Prime. As a philosophy, this is just my own personal coach philosophy. Don't try to compare your team to other teams on Long Island. Don't compare your team to what you find on YouTube. Don't compare your team to anything else. Just try to be the best team that you can be. Build the best robot that your team can build, that your team can program, that your team can bring to the tournaments and be proud of. So don't just be the best team that you can be. Learn core values and gracious professionalism. Keep lots of notes and pictures from your season. You're going to have many, many weeks of building and programming and outreach events, hopefully, and lots of stuff going on. So keep lots of notes and pictures at the end of the season. You're going to be very happy you did so when you need content for your engineering notebook and what you want to present to the judges. Consider volunteering. There are many volunteering positions. As a coach, when I started 8 years ago, oh my God, 8 years ago, when I started as a coach, I almost immediately started volunteering as well. And I found that it definitely helped me understand how to be a better coach, how to be a better volunteer at the tournaments, and what the volunteers are experiencing when they're at the tournament. So definitely consider volunteering. We're always looking for judges, referees, and my favorite core value, the last one, have fun. If everybody's having fun, everyone's going to want to be there. You're definitely going to have a successful season if at the end of the season, everybody's having fun. So I think that's it. I think that's where I'm at. So I'm going to stop sharing. Does anybody have any more questions? Would you go over the, yeah, I'm sorry. I don't know the rules on the jig. I'll see what I can do about finding that and posting it on the First Long Island website. I'll get it over to Rick. So to go back to that, the position keeps going negative. Yeah, it's because the motors are this way instead of this way. You'll figure it out. And it's mirrored because I'm on the Zoom call. So you'll figure it out. The motors are turned back the other way. Any other questions? I'm here available for questions. Wow, we went really long, 11:47. Sorry, I kind of went on. Hope I haven't put anybody to sleep. We're good. Rick, you still with me here? Recommendations on the mechanical build aspects, how to build a hammer, mechanism, forklift. There's just a lot of trial and error there. I don't really have recommendations on how to build. I'd leave that up to the students to do the research to figure out what works best. I actually can give you one recommendation. Many times I've seen students come up with a piece in their hand and they'll go, oh look, I can lift this lever with this Lego like this, but they're using their hands to do that. Oh, look, this is really easy. Now, when you attach that lever to the front of a computer and you drive 6 feet to get to that mission, you're going to show them that it is not easy. These missions are purposely designed to be difficult on purpose, very specifically to challenge these students to see how they do it. But specific recommendations on how to build tools, it's trial and error and watching tutorials online and going through any educational materials that you can find. That's what we found works. And again, as coaches and mentors, we can recommend, hey, there's other ways you can solve that mission, but leave it up to kids to find as many different ways they can to solve that mission, and they'll find ways to do it. Definitely, I promise. One of the pitfalls I fell into also was a kid would come up to me and say, oh, I know how to solve that mission. We can use these 93 pieces with 4 motors and lift it this way. And as a coach will say, oh, no, that's quite impossible. You can't do it that way. Let them try. Very often I've been surprised when they come up with an outlandishly ridiculous idea on how to solve a problem, but they end up finding a completely different solution to one that I wouldn't have ever imagined. Many of the students are unrestrained by doubt. They don't have doubt. They have full confidence in their madness methods of solving them. Let them try. It really works out really well. Anything else, please hit me up. Oh, there's Rick. How you doing, Rick?
How you doing?
Good.
I have no questions, no concerns. I just want to, as a time check, it's about 10 minutes till 12, and
Yep.
we have no time ending that's absolutely required, but I don't want anybody to feel like they have to stay just because.
Yep. It's still daylight. We're good. Yep.
And I have put some links up on the training page on our website, including 2 that Chris asked me to add today for Builder Dude 35 and EV3 lessons. So I think those probably, if you didn't mention those already, Chris, they're ready to go up there.
Yeah, those are wonderful resources that we've relied on for many years. They're really great. And again, those lessons from Builder Dude and from EV3 lessons, they are suggestions. They are not the be all end all of all answers. They are tools to help you achieve your goals. So they're not, those examples of the programming that they have posted won't work for your robot. They just won't. They're going to be guidelines for your robot, but you're not going to have the same sensors, the same ports, the same driving motors. So those are guidelines for you to use as you go forward. I even went over all my notes. I think I'm good here, Rick. I don't see any more questions here.
All right. Well, thank you all for coming today. We this is one of our favorite days of the year because we know that it's instrumental in helping keep people get up to speed. If you still stuck, well, this crowd's probably not going to get stuck. It's more the basic type, but you know, feel free to reach out and we'll try to hook up what we can. And in the meantime, yeah, there's some links up there. We may be doing a questionnaire here. I'm thinking about a couple things coming up this season. We'll see. So look, keep your eyes out for that, and hope to give you some answers on the season as well soon. So thank you for coming. We are going to try and get all these recordings up. As I said, some of them are up there already, but this one's still going. So a little hard to get that up there now. So we'll get that as soon as we can. Okay. And thank you very much. I'm going to head over to the other one, Chris, and just feel free to shut down when you think it's appropriate.
All right, I'm just going to give it another minute here. If nobody has any other questions, I don't mind. Yep, these resources will be available to you. And I wish all the best of luck. It's my goodness, I'm going on a 9-year journey here, and it just keeps getting better. I'm actually I'm personally graduated with some of my first LEGO League alumni into First Tech Challenge now, and that is whole new set of challenges that I hope you all get to experience. It's really great. In fact, I've had some of my original first LEGO League students are now off to college. Can't believe I'm saying those words, but they're off to college and they're doing very well. I have Rochester Institute of Technology alumni. I have the WPI alumni. I have one environmental sciences alumni. They've gone on to really wonderful science and engineering through, and I feel some of the skills that they learned were through this wonderful program. But you already know that because that's why you're here. Excuse me. I'm kind of meandering here at the end, just hoping for any more questions. If not, I guess I'm going to sign out. We're good. Just if everyone's okay with that, if you just want to put a little okay, good in the chat. I don't want to cut anybody off if you have any more questions. Oh, okay. All right. So we're signing out. Okay. Robin, Jonathan, Joe, and Janine. Okay, good. Okay, good. Perfect. All right. So I'm going to sign out. I'm going to say have a great day. Have a great season. We're very much hoping to see you soon at the tournaments, and I'll be there. Have a great day, everybody. Thanks for coming.